So in physics, one of the problem-solving strategies that we do involves a lot of trigonometry, specifically right-angle trigonometry, so things with a right triangle like this. So I want to just really quickly review some of that math that you've learned before so it's fresh in our minds when we move forward. So you guys might remember if I've got a right triangle like this and the angle that I'm interested in is in the bottom left corner, then the way that I label the sides of the triangle, the longest side, the side opposite the 90-degree angle, is the hypotenuse. The side here is called the adjacent side, and the side here is called the opposite side. And we had a mnemonic to help us out that was SOHCAHTOA. That told us that sine was opposite over hypotenuse, like that. Cosine theta was adjacent over hypotenuse, here. And tangent was opposite over adjacent, like that. When we're using our calculator to do these problems, we need to be sure that the calculator's mode is in either radians or degrees based on the way the angle is given to us. If the angle measure is given in radians, we need to be in radians. If the angle measure is given in degrees, we need to be in degrees. Most of the time, angle measures will be given in degrees in this class, at least. Now, if you're taking both AP Physics and Calc, or AP Physics and Calc, or something like that, then you will be constantly switching between radians and degrees. So you have to get really be very aware of that. Anyway, let's try a couple of problems just to jog our memories how this works. So it says, on a sunny day, a tall building casts a shadow that is 67.2 meters long. The angle between the sun's rays and the ground is 50 degrees. Determine the height of the building. So this is a pretty plausible problem that we could do. We could actually use an angle indicator, which is just a little tube that we look through. We would look not directly at the sun, but somewhere around the object that we're looking at. And it's got a little angle marker on the side of it, and it could tell us the angle of, in this case, elevation. The angle of elevation is 50 degrees. Then we can measure the length of the shadow, and that would tell us, in this case, help us get the height of the triangle, which gives us the height of the building. So we know this angle is 50 degrees. We know that the adjacent side is 67.2 meters, and we're looking for this side. I'll just use the same variable as them. So we've got the opposite and we've got the adjacent. That suggests that we should use tangent. So we're going to say tan of 50 degrees is equal to opposite over adjacent. And then we'll go ahead and solve. So this will be height of the building, 67.2 meters times the tangent of 50, and we'll have to use our calculator to solve that. And we get about 80.1. Let's do 80.09. And we don't want to leave off the units, so it's meters. So there we go. So nice quick review of some trig. Another thing that we commonly have to do using trigonometry is the arc trigonometric functions, or the inverse trig functions. Either name is fine. In this case, the functions take a ratio and give an angle measure. The original functions, like let's say sine, took an angle measure and gave us a ratio. Okay, so that's why they're called inverse functions. In this case, we gave it an angle. It gave us a unitless ratio. In this case, we give it a unitless ratio, and it spits out an angle. Now, there is one problem we have to be very aware of, and I want to kind of remind you of this. Let's say that we've got a triangle in the coordinate system that looks like this. And so the length on this side is 3, and the length on this side is -3. So if we're coming down here like that, so here's our right angle, this is our hypotenuse, adjacent, opposite. That's the angle we're interested in. Let's look at what our calculator says the angle is. So we'll do the arctan of -3 over, so we're going to do opposite over adjacent, -3 over 3. And we get our angle as -45 degrees. Remember that negative angles rotate clockwise and positive angles rotate counterclockwise like this. So in this case, this is correct. That angle, theta, is -45 degrees. Now, some other ways that we might express this, let's say that this is actually a cardinal coordinate system. So this is north, south, east, and west. We could say, instead of -45 degrees, we could say 45 degrees south of east. Or we could say 45 degrees. In this case, we'd be talking about this angle here, east of south. So there's a lot of different ways that we can express directions of angles, and the way that you're going to communicate them clearly to me in your homework is by making sure that you always draw a diagram. These two would be the most common ways to express this angle, and both of them rely on drawing a diagram first. If you just tell me -45 degrees, that's not good enough because I don't know how you oriented your coordinate system. So we always need to draw a diagram in physics, and that's a habit that we'll need to get into. Now, let me show you the point that I'm trying to make here. Let's do a new system that looks like this. So here's our angle that we're interested in. And this is 3, and this is -3. And let's try to find what that angle is. So in this case, theta, I should have written this out over here. We got that by doing the arctangent of -3 over 3. So in this case, theta is going to be the arctangent of opposite over adjacent. So in this case, 3 over -3. And if we type that into the calculator, you can imagine we're going to get the same answer, which is a problem. We get -45 degrees. Now, this angle is obviously not down here. It's opposite that angle, or they're vertical angles if you consider the transversal. So the problem with the arc functions, the inverse tangent, inverse sine, inverse cosine, is that they have a tendency to give you the wrong answer in certain scenarios. Basically, if you're in quadrants 2 or 3, your calculator will always default to giving an answer in quadrants 1 and 4. So we have to use a diagram to check. So your calculator told you that the angle was -45 degrees, but we know that that is incorrect. We would know that this angle is actually 45 degrees shy of 180. Remember that the straight line is all 180. So 45 degrees shy of 180 would be 135 degrees. Or another way that we could write this, again, if we had a cardinal coordinate system, we would write that this was 135 degrees north of east, or we could write that it was, and we would be giving this angle here 45 degrees north of west. Okay, so those are all ways that we could discuss that angle. In this case, these are the two most common that we would use. But again, the diagram is very necessary to communicating these things clearly. So let's try this problem. It says a lakefront drops off gradually at an angle of theta. For safety reasons, it is necessary to know how deep the lake is at various distances from the shore. To provide some information about depth, the lifeguard rows straight out from the shore at a distance of 14 meters and drops the fishing line. By measuring the length of line, the lifeguard determines that the depth is 2.5 meters. What is the value of theta, or the incline, and what it would be the depth if we were 22 meters away from the shore? We're going to break this problem into two parts, like they've suggested. And again, we're going to get into the habit of drawing a diagram to start all of our problems off. So we're going to draw just the bit of that system that we're interested in. We're just going to generalize it as a triangle. So we've got theta there. This is 14.0 meters, and this is 2.25 meters. We can see that we need theta, so the inverse trig functions give us angles. So we're going to have arctangent of 2.25 meters over 14.0 meters. That's going to give us something. By the way, arctangent, that little symbol -1, does not mean tangent to the exponent -1. It's a convention that means inverse. So don't use an exponent. It's a convention. It's a little bit confusing, but that's the way everyone decided to do it. Okay, so we know that our angle is about 9.13 degrees. So there's one of our answers. And the next thing, we're going to draw another diagram. Now we know the angle, and this is 22, and this is unknown. This is a depth d. In this case, we need to know the length of a side, so we'll use the standard tangent, not the inverse tangent function. So we'll say tan of our angle, 9.13, is equal to opposite over adjacent, so d over 22, and then we can solve for d. So we'd have d equals 22 tan 9.13, and let's see what we get. All right, so about 3.54 meters would be our depth. Let me show you something really quickly. If we have multi-step problems here where the answer from the for the second step depends on the answer from the first step, we could introduce rounding error by rounding in the middle of the problem. So one thing that we could have done is this. We could have taken our answer from the first step and we could have stored that answer into a variable. So we press the store button and then we store it into a variable. Let's say we store it into the letter A. And then we can use A later in the problem. So then we could have done 22 tangent A. And you'll see we get a slightly different answer. So in this case, the rounding wasn't a significant source of error, but it can help on the test to reduce error for multi-step problems. You guys are going to want to go to the calendar, make sure that you guys read the pages 1 through 19 and do the problems that are assigned.